110. All right, so we're going to start looking at just vertex form and what all we can do with vertex form to change what a quadratic looks like. Okay? We're going to start with this. This is called the parent function. It's the most basic function of a parabola. Nothing has happened to it, right? It's x squared, so it's a parabola, nothing else. It hasn't been moved, it hasn't been flipped, it hasn't been stretched, nothing. It's basic. That's it. Okay. So let's fill this out and graph just the parent function so we're very familiar with what the parent function looks like. Okay, if I put 0 into x squared, what do I get out? 0, right? If I put in 1, okay. 2 is 4, right, okay, great. So now let's graph those points. That's the point 0, 0, 1, 1, 2, 4. Yeah. Yeah, it opens up. Now it has an axis of symmetry that goes down the middle. It's right here. So that really is an axis of symmetry. What's happening on this side? Right, the same points, just on the other side. So there's a point here and a point here. So we can graph that parabola just using 3 points. Yeah, see, what's that called again? The parent function. That is the parent function. Okay?
Function of a parent?
Yep. Yep, like your mom and dad parent, yes. Look on page 111. We got some definitions of 11 that we need to just review, okay? First are the reference points. We've been using reference points all year. I just didn't call them reference points. Reference points are the points that you always go back to see what a function is going to look like at that point. I like to use -2, -1, 0, 1, and 2. Those are my reference points. I put those in just to see what's happening with my function at those points. I always refer back to them. See, refer back and reference. All right, our reference points are these. These are going to be our reference points right here. Those are going to be our reference points, okay? We're going to go back to these points to see what's happening and what's going on with our parabola. Remember back from geometry. Transformation. It's a movement of all of your points. And then we had some transformations that were rigid transformations that didn't change the shape or the size. Just like picked the whole thing up and moved it somewhere else, or turned it one way or the other, but it didn't make it bigger or smaller, it just moved it. Okay? Rigid motion, that's a transformation that doesn't change the size or the shape. Like a translation or a reflection. Okay, those don't change the size or the shape. You think of another one that doesn't change the size or the shape?
Rotation.
A rotation, yes. Rotation just turns it. It doesn't change the size or the shape. We just answered number 1, by the way. Now, we're going to look at question 2, and we're going to talk about what we have written here, okay? So, we picked a random vertex to use. We picked the vertex 2, 3. And we compared what happened to the parent function with what happens with the vertex 2, 3. If this is the parent function, what's happening with 2, 3? It moves over to the right, and it moves up, right? Exactly. It moves over 2 and up 3. That's exactly what happens. Because H, if it's in the H place, remember this is H, and this is K. If it's in the H place, H moves the vertex horizontally. Either a positive moves it to the right, a negative moves it to the left. K moves the vertex vertically. A positive K will move it up. A negative K will move it down. Yes.
Parent function is the middle always going to be 0, 0?
The vertex is 0, 0, yes. The y-intercept is 0. Spacing, yeah.
What is that what you mean by
X minus H, that's what it looks like. It looks like X minus H. Negative moves left. It looks like X plus H, but there's actually a negative in there because it's X minus negative H. When you finish getting this written down, go ahead and look over on page 112. We're not going to do anything different, but you need to be prepared to see different letters other than H and K. Because HK refers to just the vertex, but actually every single point is being moved. So they are going to start referring to how much is being moved as C and D. It's the same thing, but when I say HK, you need to think vertex. If I say C and D, you need to think about moving every single point. Because think about it, here's my parent function, and let's say that I did have a vertex. What was that last one, 2, 3? Okay, let's say I did have a vertex of 2, 3. So I have A, X minus 2 squared plus 3. If I just move the vertex 2, 3, because the vertex is at 2, 3, but all the other points stay the same, like, how is that even going to be possible? That can't happen, right? Everything moves over 2 and up 3 on the whole graph. The whole graph will move. The whole graph will move over 2 and up 3. every point moves over 2 and up 3. But we don't want to say every point moves HK, because HK is specifically the vertex. If you hear HK, you think that is my vertex. So we call how much it's moving C and D. Same thing, it's just got a different name. So be prepared to think about that. The C is going to be the same as the H. The K is going to be the same as whatever is here plus D. It's going to be the same. Just be thinking about that's happening to every point, not just the vertex. Happening to every single point. Okay. So let's look at one. Look at number 4 on the next page. Minus 4 plus 2, x minus 4 plus 2, that's what we were given. And we want to know how all of these points are going to change. Well, on this one, it's going to add 4, and it's going to add 2. It's going to add 4, it's going to add 2. It's going to do that to every single point until you have all brand new points. Now we're going to graph one. This is what's going on right here. I just have x minus 2 in parentheses. What's happening to that? Add 2. Is anything happening to the y? No, nothing's happening to the y. So what is this point going to become? And this one? And this one? Okay. Graph that. Looks like. You don't have to do the 3 steps. Just pick one of these graphs you want to graph it on and graph it. Graph the entire parabola. Remember, you're going to have an axis of symmetry. You can mirror the points. Graph the new one, the one in red. The vertex is still the vertex, it's just in a different place. Okay, so what's the new vertex? 2, 0. That's right here. Since it's the vertex, it has an axis of symmetry that passes through it. I have a point at 3, 1 and a point at 4, 4. I also have mirrored points to that on the other side. That's what my graph would look like right there. do number 6 by yourself. So what is this first point going to turn into? -2, -3. Why?
CD that we said.
Yep. Uh-huh. Yep.
It would be -2 -3 and 0 -2 and then 0 -3
Exactly. Those two numbers right there. They tell you that. Okay, so this one's going to be 1 minus 2, which is what? -1, and 1 minus 3? 2 minus 2, and 4 minus 3? Okay, so I'm going to graph it now. The vertex is still going to be at -2, -3. That's still the vertex. It didn't change being the vertex, it just changed where it was. So that's still the vertex, and it still has an axis of symmetry going through it. And then I have a point at -1, -2. It's got a mirror image over here. 0, 1. It's got a mirror over here. There's my parabola. If you can get it down. Alright, let's look at the next page. You just have a little bit on this page. So a translation is a type of transformation that shifts an entire figure or graph the same distance or direction. C goes left if it's less than 0, which means it's a negative. It goes right if it's greater than 0. If it's looking at D, it goes up if it's positive and down if it's negative. So basically what's happening here, xy becomes x plus c, y plus d. That's what happens when you're shifting it and doing a translation. This is not in your book, but we are going to go over it. I'll make it bigger. Nope. There you go. That's better. Alright, describe the transformations associated with each function with respect to the basic function, the parent function f of x equals x squared. So you just have to write out what happened to each function. Where did it move? How did it move? How many units did it move?
So are those new vertices?
Those are the new functions. How much did the entire function move? In which direction?
Oh,
Alright, what happened on A? Went up 8. Did it do anything else? What? It's not inside. Inside parentheses is left and right. Outside parentheses is up and down. So on A, it went up 8. So what happened on B? It went right 2. Parentheses. If it's a negative in parentheses, then it's a positive when you take it out. So that's positive 2 is to the right. Okay. Alright, so C, left 5, down 6. Yes, very good. How about D?
Left.
0. Wait, 0.
Left went up 4 and then flipped.
So this is
Remember the negative determines concavity? Yeah, they really got you on that one. It's kind of a stinker
So
maneuver.
it's down 4.
No, it's up 4, then flipped.
Oh.
Oh, so
So,
flip side.
Flips the whole, it goes like from here to here.
Oh,
Flips
so
the whole
so
thing.
it's just telling you that it is reversible to the negative.
Yes. Yeah.
Oh,
Yeah.
okay.
Yeah. Alright, so how about
So it was right. I did
E?
Right.
Right 5, down 7, then flip. Yes.
Yeah, you go up 4.
Right 5, down 7, then flip.
So it's basically I didn't even know this was
Yes. Concavity.
Yeah, we can learn
It's called.